On this week's Carrier Wrap, we take a look at the 5G fixed wireless panel from our recent Enterprise IoT event in Austin.
Hopefully everybody's gotten their coffee and ready to head back over here to the main stage for our final two sessions for the day. So if our panel members can make their way up, that'd be fantastic. Burj, here you are, always on time. Appreciate it. I didn't want to say anything, but I'm trying to be nice to you there. And Boris, Marcel, all right. Hey Boris, how you doing? And Farouk, how you doing? Good to meet you. Good to meet you. All right. And Farouk, I know I saw him around here earlier. Let's see if we get him up here and we get started and get out of here on time.
Start without him.
We'll give him a minute. I saw him around here. He's around.
He'll come.
Farouk, oh, there he is. He's coming this way. All right. All right, so we'll finish up here and get my notes out. There it is.
Where'd he go?
I just saw him. Is Farouk out there? I can't see anything. Oh, there he is. Okay, sorry for that. I know I saw you there. Okay, no problem. I'm just going blind up here. Actually, let me grab my glasses while I'm at it too.
These lights are terrible. They're right in your eyes.
You can't see anything.
At least when you're standing there, it's a little different.
All right. Where are my glasses? In my pocket, of course. All right. Head on up there. We should be good.
Do you have sunglasses?
It is bright up here. Can't see it. I mean, the 1,000 people out there, we can barely see you. It's amazing.
But, looks like the audience is full, right?
It's jam-packed. It's impressive. Well, again, all right. Well, thanks, everybody, for sticking with us here. We have two more panels this afternoon, but if no one's here from the earlier panels, I will say they're the best panels. So, well, Burj was here. So anyway, they're really good panels we have left here for today. Second best panels. First of all, we're going to tackle here looking at the first phase of 5G access deployments. It looks like a lot of operators are talking about 5G. I think we've all seen in the news. People can't stop talking about 5G, and at least from a marketing perspective, obviously, I think we all know that there's no real 5G yet. I won't go down that road right now, but it does look like at least the initial deployments of what will be 5G technology are happening in a fixed wireless kind of deployment. I think we've seen some of the larger operators already announce this here in the US, overseas as well. So it's becoming pretty paramount that it looks like that's kind of where we're going in terms of at least the initial deployments. And so for this panel, we're going to look at, I guess, why are we seeing this happen? Why is fixed being the first deployment model for 5G technologies? Which operators are driving the deployments? Look at some of the business model aspects of it, and also look at some of the technology and spectrum challenges of these deployments as well. And maybe that's what's causing some of these initial deployments too. So we have a lot of questions, a lot of topics. We have a great panel here to discuss it. I will let the panel members themselves do a quick introduction of themselves, and then we'll jump into the questions. So we'll start with Burj on the other side there and work our way this way.
I'm Burj.
There you go. Perfect. All right. And now we'll go with Boris.
Yeah, hi. My name is Boris Mazel. I work in Ciclo. We do millimeter wave equipment. We are the world leader in this millimeter wave space, focused on 60, 70, 80 gigahertz, with around 50,000 units deployed in 25 countries. Half of that is in the US, which is our largest market and the most advanced one. 2 out of 3 units in millimeter wave spectrum deployed last year were of Ciclo made. And the main applications that, and some of the success stories that I'll be glad to share with you are related to those topics that we are going to discuss: fixed wireless access and safe city, which is becoming the smart city, and how this technology, the millimeter wave technology, is becoming the infrastructure for the smart city applications. And this is something that is mainly related to IoT and to the topic of the conference.
Sounds perfect. Good deal. And then Farouk. Oh, is that one working? Sure that microphone's working on this one. Should we change up microphones?
Why don't we just change seats?
This one working?
Oh, here.
Is it turned on? Is that one working there? We can do that one too. If we need to, yeah, I'll switch them around there. Try that one there.
Yeah, Farooq Khan, CEO of Phaser. We are developing 5G millimeter wave systems for the licensed bands. We just heard about the new bands that FCC is opening up for 5G, 28 gigahertz, 37 gigahertz, and 39 gigahertz. At this stage, we are doing trials with the carriers for the cable industry, as well as with the over-the-top players. Thank you.
Very good. Yep, and I think everybody, if you hear a little earlier, Farooq gave a little background on the company as well during one of the presentations that Derek Curtin was moderating. So with that, let's start off with, I guess, kind of as mentioned at the beginning there, we are seeing a lot of these initial plans for 5G being focused on fixed wireless access. And I guess maybe we'll start with Burj on this. I guess why is that kind of been the initial launch plans, do you think, for operators when they're looking to do these 5G plans? Obviously, marketing is a big part of it, but why is fixed wireless deployments kind of driving the initial 5G movements by these operators?
So let's approach this from the cup half full and the cup half empty. So starting out, there wasn't intended to be any 5G in this decade. 5G is a phenomena for post-2020, and the standards were being developed between now and the end of 2019, yes, so that we would have the introduction of 5G in a, let's say, orderly way as we transition out of the LTE era. And in fact, keep in mind that the 3GPP has defined 5G as 2 releases of LTE that are coming, and they're not intended to come until 2019 and 2020. So around the world, 5G is a mobile application, is a mobile network technology, and its purpose is to reduce latency, achieve extremely high, ultra-high bandwidth and speed, and to create mission-critical network applications, ultra-reliable networks for mission-critical applications. So if you look at those kind of 3 dimensions of 5G, those were the primary areas of improvement over existing LTE networks. And again, mobility is an inherent feature in that. So the question then is, what is this 5G FWA anyway? What's going on here, right? Well, the answer is it's really not a worldwide phenomena at all. In the US, there's an effort to become the first 5G deployments in the world, to do that on a system that's pre-standard, and to do that in a way that is not mobile. So when you take away mobility, you create a lot of simplicity and a lot of ease of development. You streamline the process, and you allow for pre-standard, non-standards-based technologies to be developed and to be experimented with. Now, why are the carriers interested in that in the US? And which ones? Well, it's primarily being driven by Verizon and AT&T. And in my opinion, the way to think about it is the wireless carriers, Verizon and AT&T, are treating their wireline parent companies as a customer. So they're building wireless, fixed wireless 5G networks on behalf of their wireline customers to create a means to extend high-speed broadband, to improve its performance and extend it beyond the reach of fiber optic networks, to create wireless Fios, to create the means for AT&T to distribute content, DirecTV, Time Warner content nationwide without limiting it to where they can deploy fiber effectively, and to replace DSL as a backup technology. So this is a relatively unique situation in the US. In North America, the Canadians are watching very closely to see if this works and if it makes sense. Most of the second-tier carriers are not that interested in this. T-Mobile and Sprint have both said we don't plan to deploy fixed wireless with 5G at all. In fact, if you look at the rhetoric behind T-Mobile, they are the unfixed wireless, right, carrier.
Trademarked,
They think it's ridiculous that we're going retro and we're putting an anchor on 5G to make it non-mobile.
Yeah.
So it's a very odd phenomena being driven by two carriers, and particularly Verizon at this moment. And just to extend this one more, when we talked about spectrum, the other half of the enabler is specifications and standards. And as I mentioned in the beginning, there wasn't any intention to have 5G standards prepared in time. So there was a big fight after Mobile World Congress. They were going to split. There was going to be a non-standard and a standard. And instead, the 3GPP decided to move up and create a standard for 5G fixed wireless just for this purpose, and to move up so that that would be available by the end of 2017, so that commercial equipment could be then developed and deployed in 2018 and beyond. And so it's a huge breakthrough for the advocates of fixed wireless. And you still haven't answered the question, why? The reason why is we have a digital divide in the United States in which the haves have 20 megabit per second or greater broadband, and the have-nots have 6 megabits per second broadband or less. And that gap is widening. Just like the gap in wealth is widening, the people who get more are getting more, the people who get less are getting less. So we need to equalize this. We need to have technologies that use wireless to drive high-speed broadband into those homes beyond the reach of fiber, and this is the means to do it.
Got it. Okay.
Guys, do you disagree?
Yeah, maybe Boris. Maybe what's your view on kind of what similar,
so,
obviously different point of view from a vendor there.
Well, I'll take a different perspective here. Okay. And in the Mobile World Congress a month ago, we have Ciclo has a special relationship with Qualcomm. Qualcomm is one of our investors, and we had a booth in Qualcomm's pavilion. Every second visitor that came to our booth asked the same question: are you a 5G? So what 5G is? I think today, and in particular with related to the fixed wireless access, 5G is more marketing term than the technology behind that. And I'd like to take a look on the technology itself and not on the marketing term that describe this technology. Fixed wireless access, this is something real. This is something that we sell our products. This is something that our customers are doing. For example, and Ciclo is not the first company that invented millimeter wave, but we are the first company to bring the cost down so the business case for the fixed wireless access will work. And this is what we see from our customers. Probably the most famous customer of ours that you're probably familiar with is WebPass. WebPass, a wireless internet service provider that was acquired by Google in summer last year. And I'd say that 80, maybe more % of their network is based on our equipment, on the millimeter wave equipment. So, and the way we position that is that fixed wireless access extends fiber. So this hybrid fiber wireless approach is what drives this application. So they provide, urban internet service provider, and using this technology, they provide fixed wireless access to businesses, to SMBs, and they also provide it to residential customers, mainly in MDU. And now we get to the point where the technology is cost-effective enough to serve single-family homes. And this is the expansion of the access. So this is how I see the evolution of the fixed wireless access.
Farouk, if you want to add anything from your perspective?
Yeah. I think it's fixed wireless is just natural. It was supposed to happen. So what has happened is our last tens of meters is already wireless. Everything is on Wi-Fi in our homes, right? Tens of meters. What 5G is doing is making last hundreds of meters wireless. So what is happening for broadband access in our homes, even though we have a Wi-Fi router, it has some wire coming in. Either it's DSL, cable, or fiber. I see it exactly the same way as the cordless phone used to be. Like, remember old cordless phones? They had a wire going back, right? Even though it was supposed to be a wireless phone, right? But cellular replaced cordless phones. There's no wire phone line coming in to make voice calls. 5G is going to do the same for the data. There's not going to be any DSL, not any cable, not any fiber. So the companies that mentioned, like Verizon, AT&T, and Google, these are the companies interested in 5G fixed wireless access. Why? Because they had experience deploying fiber. It's expensive, and that's not the only thing. The most important thing is the speed of deployment. Companies spend 10 years, but only reach 10% of the population. But with 5G, the idea is, of course, there is going to be some cost advantage. But assuming there is no cost advantage over fiber, the biggest advantage is you are going to light up these 5G base stations and instantaneously cover the neighborhoods there. Like a cellular nationwide network can be deployed in less than 1 year. But fiber, if you want to bring to 100% of the population, it might take a century, because in 10 years, we only did 10%. So this is the greatest advantage that 5G is going to bring over fiber, the speed of deployment, bringing gigabits per second to the residential and business customers at a very, very fast speed. And why it is happening? Because you don't need a standard for fixed wireless access. You don't need to wait for a standard. Yep. So you have a 5G router in the home communicating with the 5G network, and this 5G router might have a Wi-Fi in there. All your devices in the home already are on Wi-Fi, your cell phones, TV, tablets, and everything. So there's no need for a standard. That's why it is happening ahead of schedule. You don't need to wait for the next decade. I mean, 5G fixed access deployments can start now.
Yeah, I think I agree. I think all the operators who were mentioning 5G deployments for fixed wireless were announcing things last year, even late in 2015, when there was no standard even in sight. But again, like you said, there is no need for really any sort of interoperability with these kind of deployments, because there's not roaming, there's not handoff involved. They're very simple, like Burj said, they're very simple deployments relatively. I'm not having to do it myself, but they're relatively simple deployments from an operator's perspective. And again, like you said, it does allow operators who perhaps don't have a fiber or a wireline presence in certain markets to go to those markets. I think we've seen some operators already, Verizon, for instance, rolling out a fixed broadband product on their LTE service nationwide outside of the normal Fios markets. And so it is allowing these operators, it seems, to kind of go into new markets relatively inexpensively, expand their offerings, and help out their wireline components by offering a less expensive deployment model for this point here. So,
but in fact, that's a very US-centric perspective on this. The rest of the world thinks 5G is mobile.
Yes.
And their use cases, their timelines are all around 5G mobility. Now, granted, what you're saying about the lack of need for a standard is correct for the US. However, if you're AT&T and you're thinking about this 5G investment as a way to jumpstart your movement toward 5G, and you deploy a lot of 5G fixed wireless access on non-standard technology, the standard makes a left turn.
Yeah.
The next thing you know, you have stranded investment, relatively speaking, and you haven't leveraged it to get to the mobile 5G that the rest of the world is going to have.
Yeah.
So one of the carriers that forced 3GPP to accelerate this standards activity and create some linkage between 5G FWA and 5G mobile is AT&T.
Yes.
And the vendors behind AT&T to insist that we not have two standards, or we not have a standard and a non-standard, that we have some way to link them and time dimension to bring them closer together so that the investments they make can be migrated from one to the other.
Yeah, exactly. Yeah, good point there. So, well, now I guess maybe let's talk a bit about what type of operators fit the mold for these kind of deployments. Like we've already discussed, Verizon, AT&T, Google with WebPass. A lot of these operators seem like they kind of are tailor-made for these types of deployments. But I mean, can we look at maybe some other companies maybe getting involved in this, like the cable companies, for instance? I mean, I guess what do you guys see as being perhaps other companies that might be part of this deployment model for 5G, whatever 5G is going to be, and a fixed wireless type of deployment? So I don't know, Farouk, if you want to, who do you see as perhaps being some other type of industries that could get involved in this deployment process?
Sure. So for 5G, you need two things. First, you need a lot of fiber, because the range is going to be hundreds of meters. These hundreds of gigabit per second data needs to be dumped to the internet. You need a lot of fiber still in 5G. And the second thing you need is spectrum, okay? And the companies like Verizon and AT&T, they have fiber. They have been acquiring fiber assets, small companies, and they have been acquiring millimeter wave spectrum as well. So cable companies have a lot of fiber, because even though the last a kilometer or less than a kilometer is coax, but then everything from there onward is fiber. So cable companies have at least one of the two things they're required to do 5G fixed wireless access. But then cable industry need to change their mindset, because until now they have not been kind of acquiring spectrum, in particularly the licensed spectrum. So licensed spectrum is the one that you require to do fixed wireless access in a non-line of sight way, because this is where the FCC provides you very, very high transmission power limits. You can really do very large distances with the non-line of sight. But the cable industry's mindset until now has been more like Wi-Fi or unlicensed spectrum. So cable companies are also a good fit for 5G fixed wireless access, but then they should be willing to acquire the spectrum needed for fixed wireless access deployments.
Makes sense. I don't know, Boris, any
Yeah,
views on that?
so we operate in a slightly different band. So V band is completely unlicensed, and E band is lightly licensed. So there is no, the cost of the license in E band is $75 per 10 years. So it's really negligible, and
Per site.
per link. So what we see, the early adopters of our technology, these are smaller operators like wireless internet service providers. And like Farouk mentioned here, the most important part for them is how to deliver those gigabit capacities in a very fast way. So, and this technology, since it is either unlicensed or lightly licensed, you get the license overnight, everything is on-site, everything is online. So it enables them, and the price point, of course, make the business case work. This technology enables them to challenge the big carriers, the big service providers, with the service that, in some cases, outperform the service that is delivered by big carriers with the fraction of time. And talking about WebPass, actually WebPass is the fastest service provider in San Francisco area. So if you go to the speed test site, you'll see that WebPass outperforms all the incumbents, and it happened by the numbers are order of magnitude. So this is one cluster of customers that take advantage of our millimeter wave technology. The other part is, as I mentioned before, these are cities, and the first part of the smart city evolution, like from our perspective, is the safe city. We see that there are a lot of projects connecting, and it is related to physical security, connecting cameras. So there are a lot of projects rolled out by the cities connecting cameras. Fiber is in place there, but it is not dense enough to provide connectivity, to provide backhaul to all those cameras down there in the downtown. And putting a new fiber in downtown area is very, very expensive. So they take advantage of this millimeter wave technology that can be rolled out in days. And once this network is in place, once this network is rolled out, there is enough capacity to provide connectivity to other applications. So The smart cities start from the safe city, connecting cameras, and then Wi-Fi access points are being added. There is enough capacity to that, and there are some other sensors, first responders, networks, traffic control, some sensors to identify the shooters' locations, etc. But the beginning of that is those millimeter wave systems that provide smart city connectivity infrastructure.
Sure. Okay. Well, I think I definitely want to make sure we cover the technology and spectrum aspect as well, but I want to make sure before we get to that point that we also maybe talk a bit about the business model aspect of this, because I think it's kind of been hinted at to this point as well, that it does seem like the business model for these kind of deployments probably makes the most sense for operators, at least for their initial deployments. I guess, what's your general view, and maybe we'll start with Burj on this, I guess, how does that business model work for operators? Is it a positive one? Again, how do they factor in the fact that these deployments, if they're not standards-based, they could be, again, like you said, if the standards take a different kind of turn, are these just, left assets in the field? I guess, what's the business model challenge for operators going down this path of these early 5G deployments?
So in order to understand that, let's look at the architecture a little bit, and there are some differences. If you look at the way AT&T is approaching 5G FWA, they're starting on the towers where they already have their base stations, and they want to get the signal as close to the households that they're trying to serve as possible and as efficiently as possible without having to deploy a lot of new fiber. So one question you have to ask is, can you directly deliver 5 gigahertz or 5G millimeter wave signals directly from a tower to the house? And the answer is some houses could possibly be served that way, particularly if they're line of sight unobstructed, but not the majority of houses or not the majority of customers. So how do you get that signal closer? AT&T Labs have developed a technology they're still working on called Project AirGig, which uses the power lines and transmits along the power lines and concentrates the traffic. And there are companies that are working with them to develop and perfect these plastic guidance devices that run along these power lines. So that's one way. Verizon's taking a different approach. They're going with neighborhood nodes, where there'll be a tall pole, particularly a monopole in a neighborhood that would then, from there, have 5G base stations and serve the hundreds of meters that we're talking about that can be achieved. But the question is, how do you get the bandwidth to that neighborhood node? And you could use fiber, or you could use some kind of backhaul to get there without having to hit every roof directly from a tower. So right now, the use cases are being studied in field trials. And not only the use cases, but the technology cases, looking at distance parameters, looking at different architectures, looking at different ways to solve this. And then associated with that, the cost structure, and then the revenue model, okay? So today, if you look at either what the cable companies are offering or what Fios is offering on a fiber direct-to-home network, you can get 50, 100 megabits per second, even 150 megabits per second service if you're prepared to spend significant amounts of money on broadband. I myself have 75 megabits per second. It's more than I need, unless my kids are home watching everything you can imagine at the same time. But 75 is pretty premium service. How many people are going to pay for that? How many people are going to pay? The other part of this is that we're anticipating the need for gigabit broadband speeds. And in that mode, you not only need a very high capacity network, you need a very big wallet if you're going to buy that service. So we're studying the use cases and business cases right now as we speak around these both architectural questions, business model questions, and also around whether you can find other constituencies to contribute to these costs, whether they're called smart cities, whether they're MDUs, as you described, kind of low-hanging fruit, planned developments. There are a variety of ways to bring early adopters into the system and to get them served first as a way to prime the pump, and then you build out from there. So I think Verizon is running 11 field trials this year.
For this year, yep.
And a variety of cities. By the way, they happen to have sold off a bunch of wireline states in order to pay for this.
Yeah, Frontier, yeah.
So, you know, it's kind of interesting. They're becoming kind of all wireless, except for a few states.
Yeah, they seem to have kind of stopped their Fios deployments for the most part, it seems like.
Their Fios deployments have been capped.
Yep.
AT&T, on the other hand, has a huge geographic area to serve. And by the way, we left off the independent telcos among those who are looking very closely at this.
Yep.
CenturyLink, Frontier, and others who
companies like that,
have very large geographically dispersed service territories and are also very interested in how they can use particularly unlicensed spectrum where they're not burdened by the cost of acquiring spectrum, but can jump in on fixed wireless at very high speeds as soon as possible.
Yeah, well, I guess maybe bridging the gap a bit between the business model and the technology aspect of this, maybe we'll start with Farouk on this. I guess, I mean, I've seen a lot of studies, not a lot, I've seen a few studies looking at the deployment of millimeter wave spectrum bands for these types of deployments. And obviously, as you get higher up in the spectrum band, the propagation characteristics go down for spectrum. And so, but that's where a lot of spectrum is available. I guess, how does the business model jive with the kind of the limitations of the spectrum? Because again, as you go higher up, you almost need to have a transmitter within 100 feet of a house if you want to get good coverage when you go higher up in the bands. I guess, how does the model work in terms of being able to, I guess, make that business model work? You know, if you've got each node serving one house as opposed to a node serving multiple houses, how does that work in terms of, as you guys view the market, you know, going with those millimeter wave spectrum bands and supporting a broad enough business plan to make it feasible for operators to do this?
Yeah. So 5G millimeter wave is not for rural areas.
Sure.
So the business case still make a sense in urban areas where the density needs to be more than 1,000 households per square mile. Because the range is limited, as you point out. The system that Phaser has developed, we can go up to 800 meters. And in our
is that on the transmit from the tower to the on the downlink?
You can deploy this on light furniture, like utility poles or light poles.
Yeah, but not
like
towers.
Not
yeah,
towers.
not on a tower.
Not towers,
monopole type of thing.
So the point is the minimum number of homes you get is 200. So it's not like if we are putting a access point for few homes.
Okay.
So when you have 1,000 households per square mile and your range is several hundred meters, because we only develop systems for the licensed millimeter wave bands, where the FCC has put a EIRP limit of more than 75 dBm per 100 megahertz. So there's a lot of power to get the range. Once you go into like 60 gigahertz and higher bands, the range gets further limited. But if you stay up to 40 gigahertz, you can still get hundreds of meters of range. But then the business case only works when the household or business customers' density is high. So business case works in the metro areas. I live in the Dallas-Fort Worth area. So when you divide like 6 million population by the area of DFW Metroplex, you get over 1,000 households per square mile. But when you go out in kind of spread out suburban or rural areas, a business case for 5G doesn't make sense.
So strictly an urban type of deployment. And you were saying you get that kind of coverage on a 3-sector type of deployment using a monopole or some sort of deployment like that?
Yeah, so the 360 coverage, but in each direction you have the directional beams. So it's not it's a 360 omnidirection, but that created by many, many beams going around.
Different way to do it. Okay. Boris.
Yeah, so
how that works with you guys?
As we understood, there are several bands in the millimeter wave space. And there are different propagation characteristics for different bands and different regulation requirements for different bands. So the E-band, the 70-80 gigahertz, it can travel distances of several miles. We have installations of 1, 2, 3 miles. This is really the last mile kind of solution. And the use case for that is either empty use MDUs or businesses, where the business case is pretty obvious. Because in MDU case, the equipment cost is divided between the tenants, and it's really no-brainer. The challenge is when you go and you'd like to target the single-family homes market.
Sure.
And the more suitable technology for that, in our view, is the V band, the 60 gigahertz band, and this is because of the business case.
Okay.
As we've seen in Jamie's presentation earlier on, the challenge is not to be lower cost or cheaper than fiber. The challenge is to make the business case work from the consumer perspective. Google put a bar of $70 per gigabit service, and this is something that is the maximum willingness to pay of the consumer for a broadband service. So you need that your equipment will make this business case work at this willingness to pay. So we took approach of developing our point-to-multipoint system based on consumer electronics technology, based on 1180 technology, which is WiGig technology, that comes at very low cost and enables us to make the business case work from the consumer perspective for single-family homes.
Okay.
So we are taking advantage of the consumer technology that mainly designed for indoor and applying our expertise and our knowledge and our know-how to make those indoor technologies work outdoor.
Okay, because it does seem like some of the initial deployments at least are using spectrum below 30 gig at this point. That sounds like, I think Verizon's using 28, AT&T's using a lot of 15 gig. But as you go up those bands there, definitely like we all kind of realize that the propagation does become more of a challenge, but it sounds like from what you're saying that even up above the 40, 50, 60, 80 gig, you can still make a business case work for these deployments then. Okay.
But you know, I would argue that one of the more cost-effective ways to drive 5G fixed wireless is to start taking the architecture and being a bit creative with it. So perhaps we're really only talking about a downlink speed of a gigabit or half a gigabit. We really don't need an uplink of that sort. And in fact, logistically, it's problematic for each household to have that kind of uplink to the network at that speed and have a symmetrical network. Now, Verizon Fios is a symmetrical network. It's on fiber. There's no reason why wireless Fios has to be symmetrical. And in fact, not only asymmetrical from the point of view of speed, but from the point of view of spectrum. So you may have a millimeter wave coming down to the house. You may have LTE bands going up to the house. And perhaps there are LTE bands that have previously been used effectively for fixed wireless that have now become back into interest again, whether they're in CBRS or even 2.5. So you start looking at hybrid technologies. You're looking at current fixed wireless technology for the upstream and 5G technology for the downstream. And when you start putting that together, it becomes a much more cost-effective way for CPE to operate. Keep in mind that if you need to duplicate a millimeter wave base station on every house, even if you cost reduce it, you still end up with a fairly significant cost on the way to $1,000, okay, at the lowest end. So if you can currently get CPE for fixed wireless around $100 or $150, that's a huge gap. And somebody has to pay for that cost. So we're thinking now that as much as there's a lot of testing going on, they're testing it under the guise of 5G. Very soon, they're going to test it under the guise of how do I make fixed wireless gigabit service practical, economical, and achievable. And let's use 5G where it's beneficial. Let's not worry about it where it isn't.
Got it.
What do you think, guys?
Well, I think Farouk, I think you guys, that's kind of up your guys' alley. I think you guys use different spectrum bands for the up and down link, correct? What you were talking about earlier, I believe.
Yeah. So not only, I mean, another advantage of wireless compared to fiber is that wireless is a shared resource. right? Because the fiber or DSL cable you need to bring to each home. The problem was you bring it to each home, then only 25% of the homes sign up for the service, right? With wireless, you are not bringing any wire to the home, so you are never going to invest in customers who are not going to sign up to your service. But this was happening with the fiber and the fixed wide broadband developments. So you will only send a CPE to a home or a business who sign up for the 5G service. And even when, for example, 100 subscribers sign up, you don't need 100 gigabit per second capacity in the base station, because not everyone is going to use 1 gigabit per second at the same time. So these are some of the advantages that wireless brings in and help reduce the cost.
Yeah, makes sense. Okay, well, I think we have about 5 minutes left. I want to make sure we finish up on time on this so we can get to the last panel as well. Are there any questions from, I can't see everybody out there. I know there's a lot of people out there. Any questions from anybody?
There are about 10 people live
while we're here
microphone right now.
Yeah.
They're all online. They're all watching
there
this on live stream.
waiting to
There's
ask questions.
millions of people on live streaming watching us. But
So while they're thinking of a question, why don't we imagine what is the relevance of this discussion to IoT?
there you go.
Because
wrap it up that way.
We're sitting at an IoT conference, not a 5G conference, not
Sure.
a fixed wireless conference. So I think Boris was wise to
The smart city,
suggest
yeah.
that smart cities are being enabled by the same technology.
Yep.
Smart cities are trying to implement advanced forms of IoT that today are bandwidth constrained. They're using technologies that are not suited for the job in many cases, or they're being forced to run fiber all over the place where it's not really very effective to do so. So I know many city CTOs that are looking at these technologies as a way to deliver very high-speed bandwidth, not just point-to-point, but point-to-multipoint.
But is this a Muni Wi-Fi thing played all over again, which didn't seem to work out? Are we gonna?
Yeah, I'll tell you, if we are forced to relive Muni Wi-Fi
That's what I'm saying.
for the 12th time, I
Yes.
mean, you know,
This is different.
not that it's different.
Okay.
Believe me, somebody cut the legs of Muni Wi-Fi off in order to dominate the broadband market.
That's true.
Now, if you want to get into a debate
Well,
about
that's a
that,
different
Dan,
debate.
we can do it. But I don't think Muni Wi-Fi died because of technology. I think it was killed.
Okay.
And maybe it was correct for it to be killed, but it is being reincarnated in a different form. Now the cities are the customers of the very same operators who killed Muni Wi-Fi in the first place. They need
Should we name
customers
names?
to use these technologies. Who are the customers? Cities. So if you were not going to let them do it and disrupt the market as they tried to do previously, let's do it with them and let's make them part of the ecosystem.
Yeah.
Make sense?
Yeah, you know, we work together. We work today with more than 60 cities directly in the U.S. And I want to refer to the Wi-Fi and to the 5 gigahertz band.
Yep.
So the thing is that in dense urban area, and you can test it by yourself. Open your smartphone, see how many hotspots you see in your Wi-Fi. So the 5 gigahertz in dense urban area became not usable because of the interference issue.
Yep.
And this is the main difference between the 5 gigahertz band and the millimeter wave. The denser the network becomes, the performance of the millimeter wave network increases, because the denser the network, the distances are smaller, and but on the 5 gigahertz technologies, the denser the network becomes, the more congested the network becomes, and it is just not usable for the applications today in dense urban areas.
The flip side of what Boris said is also true. In non-urban areas, 5 gigahertz is still a very useful band
Sure. Yep.
to do 5G fixed wireless. What do I mean by that? Well, there are companies that are playing off of the naming, branding confusion between 5 gigahertz and 5G.
Yes.
Okay? They're doing it in Wi-Fi already.
Yep.
When you go and buy a Wi-Fi router, they call it 5G. And they're doing it to make you think you're buying 5G. But in fact, there are WISPs that are now coming out with their own version of 5G using 5 gigahertz, delivering high speed, not quite gigabit, but hundreds of megabits of service using 5 gigahertz technology, and they're going to call it 5G. And they're going to do it to disrupt the Verizons and AT&Ts and compete more effectively with them. So just like in urban areas, they're being forced up the spectrum bands in order to find the right spectrum. In rural areas, they're very happy to take the scraps and make broadband out of it.
Yeah, that's true. Well, I think we're just about out of time with that there. I want to make sure we get to our last panel here, but please join me in thanking our panel members for some good insight. Thanks, guys, so much for that. And thank you guys for sticking around as well. We appreciate it. So with that, I want to bring on our last panel.